Okay, so welcome to the session. I just explained what we were going to do. I'll try it again. The agenda document is in the Kiko chat link under notes. Agenda at the top, a place for you to put in your name and your email. Let us know you're here. We're going to be in two sections today. The first section is Lindsay and Joan talking about trying to manage or trying to pull together and make work projects in documentation ecosystems. There'll be a breakout, there'll be an interview, it's a couple quick talks, an interview, and then questions from the audience, and then a breakout. Then Deanna and Dennis are here talking about tools in a documentation ecosystem. They're coming at this from a different point of view, the point of view of a tool creator. Then we'll have another breakout. The breakouts have a few questions. You can see those in the slide deck, which is also in Kiko chat. And so without further ado, we will go into the first set of lightning talks. And I believe that Lindsay is first.
Right. Well, thank you all for coming to this session. And I'm not going to provide any further introduction. I'm just going to tell you a little bit about the current documentation ecosystem that we've been working with within USGS, specifically within the scope of the kind of collections management within USGS. So to date, the National Geological and Geophysical Data Preservation Program has been responsible for kind of leading the collections management effort within USGS. Largely, the collections that we have documented within USGS in relation to the program have been from state geological surveys. Those state geological surveys are the primary stakeholder for the data preservation program, but also we're now trying to expand to provide more documentation and repository services for USGS scientists as well. To date, we have been using the National Digital Catalog, which honestly is a pretty clunky, dashboard-driven data entry point that creates metadata to describe scientific collections that are then archived within ScienceBase, which is the USGS, which is the USGS Trusted Digital Repository. The ScienceBase uses lots of different kinds of identifiers, but specifically within USGS, scientists are required to use ORCIDs to describe themselves. ScienceBase is not only a metadata repository, but also a data repository, so you can access data records there. Are you cutting me off or what? My slides disappeared, Ted.
Yeah, I know. I'm trying to get to see. Hang on.
Okay, so hopefully I can keep talking to this. So the National Digital Catalog has been this clunky entry point. It's the metadata requirements have been defined by the program. They're not based on any kind of community or international standards. So we are working to remedy this. Also, available to USGS scientists have been a couple of different metadata creation tools that can be used. They only work with CSDGM metadata standards. And we're really interested in trying to go beyond CSDGM to more community convention-based standards to describe collections and also international standards. Did I miss anything in there? So that's where we are right now. This is kind of the current state.
Libby, I'm sorry. I'm just having my computer's getting very slow and jumping around and weird things are going on here. But thanks for that overview. The next slide is a slide from Joan Demeraux from the ESS Dive project at the Department of Energy. Go ahead, Joan.
Yeah, hi. So ESS Dive is a data repository for earth and environmental science data that's funded by the Department of Energy. And I'm just going to introduce a different use case here in thinking about data ecosystems. And this is somewhat focused on biological and environmental research area at the DOE. And this involves a lot of work with multidisciplinary samples and related data. And so projects are studying things like biogeochemical responses to maybe climate or contamination or some other disturbances. So a common theme is that an environmental soil or water sample may be sent out to a variety of different labs and facilities across the country even, and then combined into numerous different analyses, and these may exist in different data files and then published online in different places and different data sets, and then associated with a variety of publications. And so we're starting to coordinate across user facilities and data systems that our users are already interacting with in this really highly multidisciplinary work, studying ecosystem processes with a variety of different data types. And samples really kind of provide a good example for how data may exist in different systems as it moves throughout the life cycle. So environmental samples and sensor data would be stored in ESS Dive, where I work. And then other data like genomics and metagenomics would be hosted through the Joint Genome Institute, and proteomics and metabolomics data would be analyzed at the Environmental Molecular Sciences Laboratory. And then the newly established National Microbiome Data Collaborative is starting to support microbiome data. And then the Systems Biology Knowledge Base, or K-Base here, enables a variety of other interesting data, like the modeling work and documenting workflows and narratives. And all of this information should be linked, but it's currently disconnected. And so we're starting to coordinate across the different systems to begin adopting use of persistent sample identifiers and common metadata that would help us link and exchange information as it's published online in different places.
Okay. So now we're going to have a chance for me to ask a couple of questions to Lindsay and Joan. The first one is innovating in an ecosystem. What's your greatest fears? What are your greatest fears? And we'll start with Joan, I think, in this case, and then we'll get to Lindsay. And Mickey, thank you for sharing the screens.
Yeah. So I mentioned that I work in community engagement and standards development. And so so far we've been working on developing common reporting formats and ideally identifying existing standards that we can adopt and then expanding on those where necessary, and working with scientists to figure out what information they need to be able to find and reuse data. So we've done a lot of work on developing these in partnership with the community, but one of my biggest fears is that we won't, as scientists won't end up adopting the identifiers and the metadata needed to support a more connected data ecosystem. That we still have a lot of work to do there, I think, in convincing people of the usefulness of it and that it's going to benefit them, and creating tools that really make that case for us and encourage people to want to do this. And then another related fear is that we won't have the resources to create the tools and make sure that these tools are useful for people. for both data contributors and data users. And to do that, we have to convince stakeholders that doing this work is worth putting resources to develop all of the necessary components.
Right. Okay, Lindsay.
Yeah, I mean, I would agree with a lot of Joan's fears. You know, you're building things that as you're building them, you are also trying to build the community around them. So it's a bit of an iterative process. I mean, certainly, I think both Joan and our effort is engaging the community at various points along the continuum, but still convincing, especially USGS scientists, because in our case, the tools that we're building currently, we have some incentives to get people to use them, our state geological survey stakeholders, but less so within USGS. So really convincing people that there's value to using the tools. And then also, you know, one of my fears is because the churn is pretty slow in the federal environment, that, you know, we're not able to maintain that kind of cutting edge tool development that also can be reused by other communities or, you know, other capabilities within the environment.
Ted, you're muted.
I'm going to skip the second question and go to the third here. What if you woke up one morning and the tools you needed, all the tools you needed existed? What would the next step be? And we'll start on this one with Lindsay.
Yeah, I think if we had all the tools we needed, we would be spending a lot of effort in developing the community around those tools, and also looking for other ways to connect those tools more broadly across these environments. So, you know, we're looking at using the tools to describe scientific collections and samples, but, you know, the metadata tools that Dennis is going to talk about in a little bit, and some of the tools that Deanna has been developing, you know, they have broad applicability as long as you can, you know, get the resources to really diversify them.
Great. And Joan?
Yeah, I think one of the first things that I would want to do is really start working on demonstrating the scientific value to promote adoption, similar to what I was discussing previously, but just, I guess, demonstrating with the data and the tools that linking this information is useful. So doing things like integrating multidisciplinary ecosystems data to look at ecological processes across broader spatial scales, or looking at processes changes over time, just starting to show the value, or at least identifying other research that is reusing the data in innovative ways, and that kind of letting like data synthesis studies and letting the science kind of demonstrate the value, and just using that to help promote the adoption of the necessary practices to have a more connected and useful system for scientists.
Okay, so in 10 seconds, Lindsay, do you have a system that's inspiring you?
You're muted.
You know, I think Geoscience Australia is a very good example of pretty well integrated systems. Ted, you're muted too. I would say the work they've done is pretty inspirational.
Joan, do you have any inspirational systems?
Yeah, my background is in biodiversity informatics. So the system that's always inspired me is the Global Biodiversity Information Facility. And it's kind of an example of how a tool, this data aggregator integrating species occurrence records all over the world, had really promoted the adoption of Darwin Core, the standard that it helps describe that information, and kind of opened up whole new areas of research in looking at biodiversity and species distribution.
Okay, we've got a few minutes left, or 5 minutes for questions for Lindsay and or Joan from the audience. So if you have a question, you can unmute and ask it.
Or use the chat too.
Or you could chat too. Okay.
Hello, this is Robert McGuinn. I just had a question about, you mentioned that Geoscience Australia had a really good system. Could you talk more about sort of what are the technologies and integration frameworks that they might be using? I've heard something about discrete global grid systems as part of their solution. Could you talk more about that?
In my limited capacity to talk about the technical aspects, I mean, I think one thing that they've done really well is that they have a pretty national level adherence to standards, and they use unique identifiers really well to connect data, samples, and all kinds of people, organizations, resources. And you know, their data delivery platforms, I think, are really intuitive and comprehensive. And yeah, and Mickey points out, you know, a lot of their work is open source, if not all of it. So that's also inspirational, I think.
No, thanks very much.
Ted, you're mute.
We had another question on how the Australians are meeting FAIR. Do we have any input on that? And also for Joan, okay, a link to GBIF.
I mean, I think from what I know in my experience, the Australians really are exceeding the FAIR standards in many ways, and you know, producing interoperable data that's, you know, analysis ready. As I mentioned, you know, using standards, using international standards, using unique identifiers for resources. I think all of those aspects are really strongly contributing to making not only their data, but their samples FAIR.
Okay. I think we're coming to the end of the, well, we have time for one more question. And there's a Geoscience Australia video.
Oh, great. Thank you.
From Robert. Okay, any other questions? Okay, so sorry for technical glitches on this end. I'll get used to this Zoom thing one of these years. The next step is to have, using one of the liberating structures, what, so what, and what next. Patty from ESIP is going to be putting us into breakout rooms with 4 people. And in a few minutes while she's doing that, we're hoping that you can reflect a little bit yourself on these questions that are in the 3 columns here. What are the benefits of the ecosystem approach? What are the challenges? Are there patterns emerging across data ecosystem examples? And what are the priorities or next steps? And then as we get into the breakout rooms, which should have 4 each, you you have a chance to talk about those questions with your fellow breakout-ees and claim one of the slides, and you can write down answers or thoughts or ideas about any of these 3 questions in the 3 areas. We have 6 slides. If you are group 7, 8, 9, or 10, or 11, I guess, take a slide, copy it, and make a slide of your own. At the top of each slide, there's a little space to put in either something to identify your group, the names of the people that are there, or something so that we can find out, that we can track you down for your great ideas later.
Ted,
So,
do you also want to explain how people access the slides?
The slides are accessible in the Kiko chat under activities, the activities tab at the top of the above the agenda. It's the 3rd tab at the very top of the meeting page. Okay,
I'm going to go ahead and create the breakout rooms now.
thank you, Patty. And John just put the slide link in the chat. Thanks, John.
Hey.
Okay, so Mickey, can you continue to control slides?
I sure can.
Okay, so we'll start into the, I hope that, I noticed that there is a lot of content in the breakout sessions. I mean, a lot of content, so thank you so much. This sort of ends the first third, the leadership project management third. Now we're going to move to the tools section, and I was asked to do a tool or do a picture that gave sort of an overview of tools. And there's a slide. Okay. And I, rather than trying to draw something, I decided that all I would do is show the teams that we're trying to get together. So in the USGS, we've got 3 different groups, 2 different groups in the USGS, and then the 3rd being Lindsay and Mickey and I, and the Association of American State Geologists is sort of a big user group. In the ESS Dive project, in the Environmental Science Systems, I'm not quite sure what ESS is. We've got in the Department of Energy many different groups and a number of groups outside of it. And of course, this happens in terms of a background. Okay, Mickey, hit click. Yeah, there we go. In the background, there's a wide variety of identifiers, of system builders, of other repositories of various kinds that we're also trying to connect to, things like DOIs or RORs or ORCIDs, things like all kinds of identifiers and tools. But then in the next 2 talks, or two brief talks, we'll be focusing back again on tools developed by Adiwig, and also tools, which is Dennis Walford, and then integrated hydrology and data science tools from Deanna. So why don't we go to the next slide and take it away, Deanna.
Hi, everybody. So yeah, I'm talking on behalf of the Integrated Hydrology and Data Sciences branch. So as part of the USGS Oklahoma, Texas Water Science Center, the Integrated Hydrology and Data Sciences branch is focused on delivering critical data to the public and our stakeholders. And we use a number of tools to achieve this, interactive map viewers and enterprise level web solutions with custom data collection and reporting tools, Tableau, and service APIs. So while we do host and manage data ourselves, we currently run 12 production databases with over 150 gigabytes of data collected on a national scale by USGS and DOI users. A huge amount of what we do relies on consuming data from others. And the key component to doing this, and it may be obvious to this group, are published web services. So the slide we're viewing now is a great representation of how the combination of various data sources can be used to develop dashboards that serve the public in a multitude of ways. In this case, our example is the National Water Dashboard. And the technical leads and developers for this product belong to the IHDS branch. However, it is a water mission area supported and led project. And the goal of the National Water Dashboard is to provide the public with easily accessible real-time information so that can help minimize the loss of life and property by providing advanced flood warning to communities. And this viewer brings together real-time water, weather, and National Weather Service flood forecast information, and is also accessible from a mobile device. So here you see some of the non-USGS data sources currently used in the dashboard. And yes, these agencies provide published services for accessing their data. And then on the USGS sources side, we currently use the National Water Information System services, as well as our own developed in-house spin-off services of this data called CWIS, which is the current water information system. And it pulls data from NWIS at scheduled 1-minute intervals using their services and combines it in a meaningful way for our developers to use in our applications. And the major benefit of this is that we're able to grab only the data we need and store a smaller subset based on a specific time range. And this greatly increases the response time of the service. So looking to the future, we're continuing to build our service API suite so that internal versions of the National Water Dashboard and other products can utilize the data inside internal USGS data stores, such as SIMS, the Site Information Management System, and SIFTA, the Site Funding Tracking Application. So we've targeted Open Data Protocol, or OData, as the standard for building our RESTful APIs. And if you're not familiar with OData, it's a great way to expose as much of a database as you want, and gives developers like the freedom to query just as they would using SQL expressions and clauses. So ultimately, it is a goal of our branch, and this may be my personal belief, but our responsibility to develop and maintain enterprise-ready service APIs for each of our managed databases, and provide the documentation and access to them for other USGS and non-USGS developers to consume.
Okay, thank you, Deanna. Now, Dennis.
I'm Dennis. I'm Walworth. I'm the data manager for the USGS Alaska Science Center. Do we have the next slide there? There we go. So there's a metadata toolkit effectively was initiated by a group called the Alaska Data Integration Working Group. It's currently being supported now by the U.S. Fish and Wildlife Service and USGS, primarily here in Alaska. And so this toolkit started several years ago, and it consists primarily, of course, of an end user interface called ND Editor, and it utilizes its own sort of metadata dialect, which we call ND-JSON. And so that dialect is sort of agnostic of XML standards, but it encapsulates those standards as well as it being extendable. And then there's another major piece of the translator that allows translation from one dialect to another dialect. So we also have this ability really to import content, if you will, into that editor environment. And so one of them can be content standards, documentation content standards, and the user interface can utilize that such that it can guide the user to specific documentation elements that they need to address. And this is what Lindsay's group has done effectively with collection standards, collection documentation standards. As well as you can import reusable modules, if you will, people, organizations, vocabularies, dictionaries, geospatial, that can be imported either as, and we can import as a service for one vocabulary, and the other things can be imported as ND-JSON components. So these things all have obviously internally within the systems unique identifiers, and the users can apply identifiers as well. And so that helps with that sort of universal reuse concept of content. On the other end, we have sort of the publication, if you will, of that documentation, which can be in various flavors, XML flavors. We also have the ability to publish that to the USGS Science Base repository. And so kind of the idea of that publication that's going out to either your own organizational repositories, databases, archives, or out to other organizations, out to our partners, collaborators, and so on and so forth. So kind of creating this sort of, I kind of think of it as almost a recycle sort of loop here, where we're sort of perhaps using the tools to create content, and in terms of reusing those contents and being able to apply them to other things.
Okay, great. Thanks, Dennis. Okay, now we have another time period here for 5 minutes for questions from the audience again. Any questions for Dennis or Deanna?
I have a quick question if I can jump in. I think it's for Dennis. I'm curious about your metadata toolkit, metadata editor. Who submits those metadata to this? Do you control who submits that, or do you get data from metadata submissions from a variety of people outside of your organization?
So it's not organizational specific. Anyone can use the tools, anyone can bring content into the tools. And so really it's up to you to sort of manage that content as you wish. You can use the tools to create that content modules, export it back out, and do with it as you wish, pass it on to other people so that they can use those same content modules, if you will.
Okay. Turn your volume up. Oh, that was a different chat. Okay. Any other questions for Dennis or Deanna? I'll ask a question for Deanna. Deanna, I think in your case, you have worked with a wide variety of different groups with these tools, both within and outside the USGS. I guess you told us about most of those. And you mentioned OData. Are you using any other standards in the sort of the mapping interfaces?
Not that I'm aware of. I'm pretty much, he does, so our developer, Joe, handles that stuff, right? And he pretty much just will use any JSON feed that he can get, right? So I don't really know if that would be considered a standard, but he's a JavaScript programmer, so he tries to get the data in a JSON format to use.
Okay. Okay, any other questions?
Maybe Dennis could comment on what organizations or communities you're aware of that have been using the metadata toolkit.
So I would say Fish and Wildlife has probably had the largest use of it. There's kind of smatterings of usage within USGS. Beyond that, I'm not too sure. We did have a couple of NGOs that have been using it here in Alaska, but I'm not sure beyond that.
Thanks.
Okay. So now we're going to go through the same mechanism that we went through before. So we have a few minutes. We'll go back into breakout rooms. I hope it looked like everybody was doing well in terms of finding slides and filling them in the last section. But now we have a few minutes to sort of just think about tools or think about these questions. What capabilities are amenable to an ecosystem approach, or what tools do you know of that are shared across your ecosystem? How have shared tools benefited you? or other ecosystem shareholders? And what are the priorities for creating a more connected ecosystem, or what are the next steps? So we have a couple minutes to think about that. We'll go back into breakout rooms with 4 people and give you a chance to talk about those ideas for 10 minutes. And then we'll be back to the whole group for just open discussion of ideas that came up during either one of the breakout sessions that you were in, either management, project management, or tools. So Patty, this would be a great time to do that random breakout room thing.
So I'm trying to figure out how to take you guys, the leads, out.
I think if you make us hosts, then we can take ourselves out. That will leave the small groups, but
I can make you guys co-hosts.
I seem to be left over.
not yet, Jeff. I think we're all left over at this point.
Oh,
Yeah,
no.
hold on just a second. I'm sorry, I'm just.
That's okay. Oh, everyone is?
Yeah, everybody's still
yeah.
here, Jeff. How are you?
Oh, okay. Yes, now I see that it says there's 33 people still here, so never mind. I didn't have enough metadata, sorry.
Jeff, you're actually ahead, not behind.
Okay, so almost there.
Coordinated with.
I'm making you guys co-hosts so you can take yourselves out. I just have to get Mickey. Okay, so
Thanks, Patty.
yes. All right, here we go. I'm going to open up all the rooms.
Okay. Well, we've got 25 minutes at this point, and I think that we're in just group discussion. So I concur completely with your executive decision. And are you and Joan going to tag off on that, or do we decide who's?
We can do.
Why don't you go ahead?
All right, well, I'll start a little bit. So Joan has been thinking about kind of documenting samples largely, and looking at systems to connect samples within the repository environment that she works with, but even more broadly across DOE. And we've been looking at how to document collections that certainly contain samples and maybe a lot of other things too. And USGS has been working on completely revamping the architecture under which we document collections to really make collections much more discoverable, trackable, give people credit for the effort that they put into collecting and maintaining collections, etc. And so in that process, we brought Deanna Terry and her team on board to help us with the software development, largely because of their vast expertise in developing the types of tools that we're looking at. And the fact that they develop really nice tools. And then Dennis, kind of in this process, we started to really think about, how can we really reduce the burden on scientists in documenting their collections and reuse tools that we already have. And so, USGS has been on kind of a long road to move towards ISO metadata compliance. And the tool capability to do that has maybe lagged where we would like to be. We have some good metadata tools for CSDGM metadata creation, but we really wanted to go beyond that, looking at more global integration, especially we're planning in the next year to implement international geosample numbers for samples within and across USGS. So really looking to try to, as broadly as possible, meet the requirements to integrate with a lot of other systems. So that was where Dennis and the ADIWIG suite of tools came in. And yeah, I think that's really what kind of brought us all together. Joan, do you want to add anything to that?
Not much. That was a great summary. I guess that we're just getting started with developing tools and thinking about how we can have better connect our data when it's published online, and eventually we want to connect to outside systems as well. And it would be one of the things we've been thinking about is just samples as one example, but we have a lot of other data types as well. Samples provides kind of a good starting point, especially since a lot of groups are kind of thinking about that and thinking about like using IGSNs or other identifiers to connect that kind of data.
Yeah, and so what we're planning to do within USGS is actually to use DOIs to describe collections of samples, and then use the IGSNs to describe samples themselves. And so, developing these tools with as many unique identifiers as possible to really facilitate, managing provenance, credits, etc. We're under more and more pressure to demonstrate the return on investment for scientific collections and samples. And that's something USGS hasn't really done through time, and we're really trying to build that into these tools.
Can you go and explain how you're trying to do that?
Yeah, so part of that begins really with kind of collection planning. So we're trying to get scientists to think about what are the investments that are necessary, not only in establishing a collection, but maintaining it. So thinking about budgets, space, tools, what are they getting out of this investment? So linking the sample collections to publications, et cetera. And, trying to find these ways by mostly, I think it's going to come down largely to the ability to trace identifiers through these systems to, really demonstrate that collections not only give value to the initial project under which they were collected, but can provide ongoing scientific value for years, decades plus down the road. And we're able to do that currently. We do that within the Core Research Center rock core collection. We've been able to demonstrate that materials that we have that came into the facility at the very beginning often are more requested than things that came in last week. So, being able to demonstrate that there's value in keeping things beyond their originally collected purpose, I think is something that we're interested in doing.
Yeah, I'll just add one comment, which is, we found it's hard also to document the benefits of things that people have very quickly come to take for granted. And, the inability to do something that you can do now, how do you quantify that? Or how do you get people to, provide those vignettes that can help sell your repository or tools that you've produced?
Yeah, we've mostly been doing that by asking our clients to provide, letters of support. And unfortunately, I mean, part of that is because, we're doing that for a rock repository where the primary users are industry and their work is very secretive. So they're not publishing results necessarily on the use of our collections, but they're very supportive of having access to those collections. So far, we've primarily been documenting that through, we can look at reuse statistics, but also asking our clients to provide letters that demonstrate how valuable the collections are to them.
So Bill, since you made a comment, that's great, but I'd like you to make at least one more comment. In the years of Data One and LTER and a lot of big collaborative projects, were there successes or things that happened in those projects that you thought were really exemplars of working across different teams?
I think some of the biggest successes were through NCs, the ability for working groups there to synthesize data, that in many cases they weren't even aware that it existed until they searched Data One and or entered data into repositories following EML standards and so on. I remember like one of the first ones that made a huge national, international splash was synthesizing primary productivity data across a large number of very different types of biomes. And that had never been done before. And the people that were trying to do it assumed that it was going to be really easy. And they found that it was quite a challenge, and then within a year after they got started and people started submitting data into repositories and it was more discoverable through Data One, then that really sped up the process like an order of magnitude, and they were actually able to get some really good synthetic results. So that's just one example there. And, it sort of comes back to a question that we talked about earlier in one of the sessions, and that is, what is the ecosystem that we're all talking about? And we automatically assume that it's some narrow, realm within the earth or environmental sciences. But, increasingly, I think we're finding that, the ecosystem is really much broader than that. When anthropologists can come in and say, hey, I'd like to link up my data with your environmental data, then that's expanded out into a whole new dimension that we weren't even thinking about originally. And I think we're just going to continue to see more and more of that down the road.
We've got 33 people here. Are there other successes that people want to mention about successes that have come about as a result of using tools across different teams, or is that, Lindsay, is that consistent with the executive decision?
I already met my requirement, Ted.
Okay, great. We've got 33 people here. We must have at least one other success, or any lessons that have been learned. We may have too many lessons, but lessons that have been learned as you try these things, or ideas that came out of the breakouts or that emerged from the breakouts.
So I'll jump in here and kind of based on some of the things that Bill said, I think the ecosystem could be very broad, but I think we'll find, like, we should find hope in mini successes, like where we're linking smaller ecosystems and then building up from there. So like not trying to aim too high to begin with. I mean, even I guess within USGS is like one space. There's so much diversity and so many disparate tools and things happening. And so, we've made some strides in connecting some of our systems through some shared vocabularies and standards and things like that. And that's been, I think, very successful for us. But then kind of taking a step back and knowing that that's just USGS, but even so, that's still a success, and that, we need to then continue working to, better integrate into broader ecosystems outside of USGS.
Well,
I
I'll
think that's-
just add a comment there as well, which is that I think, there have been some huge advances within, for example, USGS in certain areas. There's been other huge advances in some areas of NSF. But getting the two to link together and with other tools through NASA and so on, there's a lot of overlap in terms of what we all do, but there's not been, that higher level sharing, via support from the research sponsors that would, I think, really help all of us.
Julian Chastain was here a minute ago from Unidata, but he might have left. I think, an interesting thing has happened over the last couple of years with the Pangeo project, and for accessing primarily climate model results, big climate model results in the cloud. And I was in a discussion a short while ago about Pangeo with some people that have been involved in it, and it's been and yesterday during the Jupyter Notebook session, I'm now forgetting his name, Fernando Perez, one of the early creators of Jupyter, was talking about how Pangeo really built on existing tools, found the holes in those tools, or the gaps that had to be filled for those tools to be worked together. And he mentioned that as a really good example of a project that built across open tools. And Pangeo, I expect people here have learned about it. But when I was in this discussion, I pointed out that it was actually, if we go down a few layers in the stack, it was really HDF and then NetCDF built on top of that, and then the CF conventions built on top of the NetCDF that allowed the access and the sharing of all those different data sets, and the adoption by CMIT, the climate modelers of those formats and those conventions that really built a foundation, one of the foundations that Pangeo built on. So I think, and Matt Biddle, who's here and was in one of my breakouts now is at IU's, but also was at Pico Demo and NOAA before, was talking about Airdap. Airdap is another tool developed by Bob Simons out in California that is and it's been there. I hesitate to say how long it's been since Bob started working on that, because it exposes my age. But now Airdap, I'm hearing about it in more and more situations. And of course, another example is OpenDAP. OpenDAP has been around since the very early days, coming from oceanography and then into more general earth science. So I think this is sort of the kind of thing that Bill also mentioned, that we are really building on a lot of layers these days that we've come to sort of take for granted. And of course, the people that are trying to keep those layers going have a number of challenges. Any comments on that? Or Joan, do you have any successes? You are out in the wilderness.
No, I don't really have other successes to share, but I've been wondering if people have thoughts on, like, where do you start? Like, if you want to start working towards more connecting data that should be related and to better enable interpretation and reuse, like, what are our starting points, and how do we start to connect potentially related data across agencies, for example.
So this is Matthew Biddle. I wanted to bring something up. I'm trying to do my video so you can see me. Hi. There was a session earlier today that was about semantic harmonization, and it was along the lines of vocabularies and things like that. But I would highly recommend taking a look at that recording and seeing, because that's trying to draw a lot of these connections between at least vocabularies and making those connections so that everything's more interoperable. I'm probably not doing it justice because it's way over my head, but I just wanted to throw that out there.
I'm wondering too if Deanna maybe could comment on the kind of integrated data management system that they're using to connect a lot of resources from within and outside of USGS, I believe.
As far as, what our databases are built in?
What was it called? SMIS and?
Oh, the Site Information Management System, and the Site Information, Site Funding Tracking Application. So those are just two big systems internal to the USGS that our field staff uses to manage all their site information, like station documents.
And there was another one that's coming online, is that?
No, those are already online. What we're doing with those is building the service APIs that are enterprise ready and available to like the National Water Dashboard and products like that to use. So those have been actually in production and being used, for 15 years. And they've gone through various iterations and databases over the years. And then, we're at that point now where it's really trying to just get them out there and exposed so other developers can start using them more. And so that's the idea with now building these service APIs. And they have had services built on them, but not to a level that we're really comfortable with, that a large scale enterprise application could utilize. So it's just hardening up those at this point. Does that kind of answer what you're getting at?
I was thinking there was one more system that isn't online yet that you talked about.
Was it the CWIS one? The one that the custom one that we're getting NWIS data from?
Yes, I think that's it.
Yeah, that one also is being used, but just internally to us for now, but that's actually going to be a push this year to make that available to at least the rest of the USGS too, if not a wider range, because it is using NWIS data, which is public. So it could be possible that it would reach outside the USGS. But that's just grabbing data from NWIS every minute that is needed. And really it's just catching all the changes within that minute since it last had a refresh. And it just makes the database, then it stores it in a database, and then there's a service, an OData service that connects into that CWIS database for us to use in our applications. And so the database is just much smaller than the NWIS one, and the service, response time comes back way faster than using straight up NWIS services would.
Okay.
I was going to echo what Matt said, starting with semantic harmonization at the lowest level, just to be able to interoperate at sort of the vocabulary ontology level. And then, moving up the stack, you start thinking about standards and then standard services to implement those standards so that you can then connect systems to systems and start federating or otherwise interoperating. That was some of what we talked about in one of the earlier breakouts.
Thanks, John.
Yeah, I'd like to add one more thing. Sorry, this is Matthew Biddle again. So I was part of a really cool program about 2 years ago called Ocean Hack Week, and it was an effort to get people together who are interested in oceanography, who have an expertise in that, know some coding, and we can spend a week coding and doing stuff. And so one of the projects we actually worked on was, Ted mentioned this Airdap system. And so there's all these repositories that are using that Airdap system, which gives you a standardized response and a standardized way to access and query data. And so we took it on ourselves to say, hey, there's this system that all these different repositories are using. Let's see if we can search all those repositories for this one particular type of data. And so it started actually, it evolved into let's just build an ocean data search thing that looks at all these different repositories. And since they're using standardized access mechanisms and sometimes similar vocabularies, you can do this more holistic searching in this more, broad scale access and usability of the data. So I just wanted to mention that it was a really cool use case in applying a lot of these kind of organically built systems that get traction and the community starts using along the way.
Matt, did the tool that you worked on during the hack session survive? Is it still around, or obviously I guess things you learned are still around, but
yeah, it's in GitHub. The code is in GitHub, but there's been different iterations. There's actually this service called Airdap.com, which is kind of what we built it on, that is a keyword search, but we wanted to expand that and do geospatial searching and more specific vocabulary searching. So there, in some incarnation, it's definitely around and exists. It would be interesting to see where that could go in the future. And I know we've been kind of looking at it at the NOAA Integrated Ocean Observing System office as something that we could use. But it hasn't gotten major traction amongst the federal agencies, I should say.
Okay, thanks so much for bringing that up.
I have a question. I'm kind of following on that conversation on John's comments. I'm wondering if, I was thinking about that when we developed sort of the ability to publish to ScienceBase. It was a lot of work. We really had to get down into the weeds of ScienceBase to make that happen. And I'm wondering about interfacing with repositories. Is there any sort of standards mechanisms for, rather than developing a publication service for each thing you want to publish to, is there some sort of standard services that exist such that you're not building, custom publication services each time? You can just utilize that standard.
I know that Ken Casey was talking about the NOAA, or one of the NOAA cloud efforts, trying to use a self-describing, self-documenting, open API documentation, so that automated tools could read the documentation in a machine-to-machine way and automatically construct a client for that API based on that open API documentation, so that a human did not need to be involved in that order to build that adapter to talk from one service to another. That seems to be the only thing I can think of. Well, I know other people have done similar things, but that's the one thing recently that I can think of that is sort of along the lines of what you're asking about.
There was a lot of work in NOAA and related work in OGC on publication and subscription services, so pub/sub capabilities and standards for that. And of course, in the situation that you're talking about, where you're going between two metadata dialects, I think that's you're trying to look for a standard way to connect two unstandard things, sort of, or two things that are completely standard but in two different communities. So if both, if MD tools and if system A and B, let's just say, we're both using the same representation for the metadata, then then it might be a lot easier. So it's now slightly after 3:30. I think this room is ours until we get kicked out. So people are certainly welcome to stick around and ask questions or further discussion. I'd like to thank everybody for participating and being patient in as we had some strange things going on in various computers. And one of the things that we do in ESIP is collect ideas about takeaways, things that we learned or things that we want to take away from this session. At the bottom of our agenda on Schedule, there's a blank space there. If you, we would share those takeaways with the broader group that was unable to make it to this session. I assume we'll do that again during the meeting overview. But if you have such takeaways, we'd be happy to have you put them into the agenda at the bottom. Anything else from Joan or Lindsay or Dennis or Deanna?
Well, I was wondering, are we going to compile the feedback that people put into the slides from the breakout sessions? I mean, maybe we can pull some of the takeaways from there.
I think the organizers will do that. Do you want to do that now or?
No, well, I mean, not really, but I just wanted to make sure it got done because we didn't quite circle all the way around. If people want to stick around and do that, then that's fine. But
scrolling through the thumbnails, it looks like we've got a lot of input from the breakout sessions.
We
so
did.
I think that's something that we may need a little bit of time to digest.
Mm-hmm. Agreed.
But I think I'm super excited that we had over 30 people during the session. I hope that you all, these are paths that many of us have walked on more than once. So getting your input was really good. And thanks to Lindsay and Mickey and Dennis and Joan and Deanna who put this together and took over executive capabilities when someone stashed Ted away in a breakout room. It's great.
All right, well, thanks everybody for joining the session today. I think we've got some good material to work with here.
Yeah, thanks, Bill. Thanks everybody for your comments and your ideas, and have a good meeting. Poster session starts in 25 minutes. I've heard there's a great poster about data quality metadata.
Authored by Ted Haberman.
Does anybody want me to save the chat and email it to you?
Yeah, that'd be great.
Okay.
That would be wonderful. And thanks to Patty and Christine for helping us with this. And the wild and crazy, always, life was a lot easier when we had just, 3 PowerPoints to give in an ESIP session, and then not enough time for discussion.
Also very nice to see many of you that I haven't seen in quite a while. Glad to see that everybody appears to be healthy and with their hair grown out and whatnot, but wish we were all about to head to a poster session over a adult beverage. Oh well.
See, Lindsay, if you have one of these fake backgrounds in your hair, less of your hair actually shows.
I know.